Today, I'm going to be talking about first the Rao-Blackwell theorem and second the Cramer-Rao theorem. To start, I'm going to first talk about the Rao-Blackwell theorem and what is this theorem? This theorem is a way to improve the efficiency of initial estimators. These estimators are observable random variables used to estimate quantities. And if we are looking for unbased estimators with a small variance, we can restrict our search to estimators that are functions of sufficient statistics. The theoretical basis for the above observation is the Rao-Blackwell theorem. And the theorem is this one where let the estimator theta be an unbased estimator for theta such that the variance of the estimator theta is less than infinity. If t is a sufficient statistic for theta, define the estimator for theta as equal to the expected value of theta given t. And then for all theta, we have the expected value of the estimator of theta is equal to theta, and the variance of this estimator is less or equal to the variance of this estimator. And well, this theorem implies that an unbased estimator for u with a small variance is or can be a function of a sufficient statistic. If we have an unbased estimator, we could improve it by using the result of this theorem. And well, this theorem has many applications, and this include the estimation of prediction error and producing estimators from sample survey data. For example, observation in adaptive sampling are found in sequence. Each new observation depends on one or more characteristics from prior observation. And improved estimators can be also found by taking an average of estimators over every possible order. Then we have the Cramer-Rao theorem. To start, we have that in the 1940s, the Cramer-Rao bound give us a lower bound for the variance slash the mean square error of unbased estimators. This means that the best possible estimator for a given parameter will have an MSA dictated by the bound. And in the theorem, we suppose that we want to estimate theta from n samples. So this theorem states the following formula, where the variance of the estimator of theta is greater or equal to 1 divided by ni of theta. And if we have a quality in the bound, then we know that the estimator is efficient. This doesn't mean that there are always exists such an estimator. However, it does state that the best possible estimators, MSA, will be bigger than or equal to the one given by the bound. And well, as we see, these two theorems are ways to improve the estimators that we are calculating. And here we have the references.